All right, so we're gonna look at confidence intervals and drawing conclusions today. It's gonna be a little bit more writing than normal, but it happens. So I always start with this example of trying to guess my age. So pause the video, take a second. I want you to try and guess my age. So take a second, write it down. It's gonna help you understand it. So now that you've done it, guess my age. My age is actually, oh, I didn't change my things. Pause. All right, unpause. Actually, 35. I will turn 36 in July. So now to create an interval is kind of what we're going to look at. So the margin of error is kind of what we're going to look at. So now create an interval by subtracting and adding the 10 years. So my interval here would be 25 to 35. So give a percentage for how confident you were that my age is actually within that interval. So that would once again be 27 plus or minus 10. So within that, 97% confident you could be within that gap. And that's 10 years. If I had 5 years, it's going to be a little bit smaller. So that would be between 30 and 40. That's a mistake up here. And that would be 45. So somewhere in between 35 plus or minus 10. Sorry. This would be 35 plus or minus 5. How confident would you be there? Probably about 80%. So now create within 1 year. So that would be 34 to 36. So it's 35 plus or minus 1 year. And that's a 60% confidence interval. So the number you subtracted and added is called your margin of error, or just your error for short. We're kind of looking at it. So as the error decreases, what happens to your confidence level? So as the error decreases, the confidence interval is always going to get smaller. Smaller, I know I said smarter, but you get smaller, which leads to a reduced confidence interval. So leads to a reduced confidence interval. All right. So what you got here is a confidence interval is a range of values that we are fairly sure our true value lies within. So we're just kind of guessing in this. So stat is all about using data from a small sample to gain inferences or to make inferences about a total population. So that's what statistics is all about, is looking at a small piece and trying to make an inference about an entire population. So your margin of error. If you look at this is now pretty much margin of error is how off we allow our guess to be. The confidence interval is the interval that we know it fairly lies between. So pretty much it's guess minus the error. And then your guess plus your error. Will always give you your confidence interval. So guess plus or minus your error. All right. And I'm not going to write out in words a lot today, but you can start writing it. So in the Washington orchard, you randomly pick 30 apples. The mean weight of the apples in the sample is 86 grams. So find a confidence interval and interpret your data. So what we're going to do here, I skipped this, sorry. The margin of error, if it's not given, we're going to estimate by using 1 over the square root of n, and n is our sample size. Okay? Sorry, my fault. So we're picking 30 apples. The mean weight here, so my guess would be 86. So my margin of error is going to be 1 over the square root of n, which is 86. So 1 over the square root of n. Sorry, I apologize. Struggling. N is my sample, so it's 30 apples. So 1 over the square root of 30 is roughly 0.183. So my confidence interval here would be 86 minus 0.183, so 85.817, and then 86 plus 0.183, which is 86.183. So what we're saying here, here's my confidence interval I found. So we are going to be fairly confident that the mean weight of all the apples is somewhere in between 85.82 or 817 and 86.81 or 183 grams. That's what we're finding today. We're just finding confidence intervals, so a range that we can guess into. So let's look at B, and I'll write this one out in words. So in a random survey of 710 teens, their average battery level of their cell phones was 86%. So find the confidence interval and interpret the context. So here, my guess is 86%. My error was not given. So it's going to be 1 over my square root of my n, which was 710. So 1 divided by the square root of 710, you get 0.0375, which is roughly 3.75%. Okay? So your confidence interval would be 86 minus that and 86 plus that. So 82.247%. And then 86 plus the 3.75 would be 89.753%. So what this means, and I'll write this one in words so you can see it, and that's a 9. So if you wanted to put it in words, we are going to be fairly confident that the average battery level of teen cell phones, is going to be between 82.247% and 89.753%. And that's how we would explain it, and that would interpret our context. So we're not going to be confident. We're always going to say we are fairly confident and then state what it is, that the average battery level of the teens' cell phones is going to be between our confidence interval. And that's what we're doing today. All right. Let's look at a few more. So according to the recent 2013 government study using 99% confidence interval, the average 4-year education at a public college or university will cost about $8,944 per year with a margin of error of plus or minus $1,500. So what's the minimum average? So we're going to take these two, subtract them. So that would give me what, $7,444. What's the maximum? So I'm going to add them. That'd be $10,444. And you're good to go. It's kind of looking at it here. So once you got that, the error was already given, so you don't have to do much. And you can say, what's the min, what's the max? All right, so it's determined that 44% of people would vote for the Republican candidate for president in a city with an error of plus or minus 4%. So let's find the confidence interval and interpret the context. So I'm given my error and I'm given my percentage. So the confidence interval would be 44 minus 4, so 40%. 44 plus 4, so 48%. So what does that mean? It means that we are fairly confident that the percentage of people who voted for the Republican candidate is between 40 and 48%. So once again, we are fairly confident that the percentage of people who voted for the Republican candidate is between 40 and 48%. That would be your interpretation. So in order to win, the candidate must have 50% or more of the total votes. Can you determine this candidate would win or lose? Okay, I would say lose, since 50% is higher or above 48%, which was our confidence interval. Since it's above, at most, he would have 48%. And that's how you could explain that. All right. So in an election, the Republican candidate has 51% of the votes with a 3% margin of error. Democratic candidate has 43% of the votes with a 3% margin of error. Is it possible for the Republican candidate to win? Is it possible for the Democratic to win? So let's look at it. So the Republican candidate and your Democratic. So Republican is 51 plus or minus 3. So that would be 48% and 54%. Your Democratic candidate is 43 plus or minus 3, so 40 to 46. Is it possible for the Republican to win or lose? So it is possible for the Republican to win or lose because the interval contains values below 50% and above 50%. The Democratic candidate will definitely lose because at most he gets 46%. So the Republican could win or lose, we don't know, because 48 is below 50. So you got the range is above and below 50%. The Democratic will lose because the maximum is not up to 50%. Cool? So a journal stating that 57% of people enjoy drinking coffee with a margin of error of 9%. What is the confidence interval for people who enjoy drinking coffee? So we got 57 plus and minus 9. So 57 minus 9 would be 48%. 57 plus 9, would be 66%. So we can't conclude that a majority because 48 is less than 50. So no, can't conclude. Because 48% is less than 50%. Cool. All right, and the last one, let's get our confidence interval. So a newspaper published an article about puppies' weights. The average weight is 128 newborn puppies. It's 270 grams. Is it possible to conclude that the average puppy weight is above 265? So my guess here is 270 grams. My error was not given, so it's going to be 1 over 128, and that's the square root of 128. So 1 divided by the square root of 128, because that was my sample size, which is 0.088. So my confidence interval here is 270 minus that, which is 269.912. And then I got 270.088. So is it possible to conclude that the average puppy weight is above 265 grams? Yes. Because my smallest one is 269.912. Cool? So that's confidence intervals. So make sure you got it here. The big thing here, confidence interval, is your guess minus your error, and then your guess plus your error. And if the margin of error is not given, it's always 1 over the square root of n, where n is your sample size. So hope you have a wonderful day. If you got questions, please let me know.